Hello, and welcome to Architect of Sleep. Tonight, we are leaving the noisy world behind to travel on a quiet drift through our cosmic home, the solar system. It is a place of deep silence where giant worlds hang like jewels in the dark, and time is measured in slow, graceful orbits. Here, the only sound is the gentle pull of gravity, a force that holds everything in a silent, cosmic ballet. For now, just breathe. Let your eyes grow heavy and allow your mind to soften. Our journey begins now. At the very center of our journey, there is a star. It is our sun, the great anchor of this family of worlds. It is a vast ball of glowing gas, holding every planet in its steady, gravitational embrace. Its light and warmth radiate outwards in all directions, touching everything. It is the silent heart of our solar system. This star is not solid, like the ground beneath your feet. It is made almost entirely of two simple gases, hydrogen and helium. The sun's immense gravity squeezes these gases together, creating incredible pressure and heat at its core. It is a sea of fire, contained only by its own weight. This process has been happening for billions of years, a quiet, sustained reaction. It is a giant self-contained furnace in the vacuum of space. The sun's energy is born from a quiet, constant transformation. This process is called nuclear fusion. Deep within the core, hydrogen atoms are gently fused into helium atoms under immense pressure. This simple change releases a tremendous amount of energy as light and heat. It is a slow, steady conversion of matter into pure radiance. This is the sun's quiet heartbeat, a pulse that has beaten for billions of years, a gentle alchemy, turning matter into light. The light you see from the sun is older than you think. The energy, in the form of photons, is created in the sun's core. But it does not travel in a straight line. It bounces from atom to atom, on a long, slow journey outward. This random walk can take tens of thousands, even hundreds of thousands of years. After this long, slow journey to the surface, it takes another 8 minutes to cross the empty space to Earth, a long-traveled gift of light. The sun is so large, it is hard to imagine. Its diameter is more than 100 times that of Earth. If the sun were a hollow sphere, you could fit nearly 1 million Earths inside it. It contains over 99% of all of the mass in our entire solar system. All the planets, moons, and asteroids combined are just a tiny fraction of its weight. Our entire world is just a tiny blue speck next to this glowing giant, a humbling reminder of cosmic scales. The visible surface of the sun has a name. It is called the photosphere, which means sphere of light. This is the layer where the hot gas becomes transparent, allowing light to finally escape into space. It is not a solid surface, but a churning layer of bright, grainy cells of plasma called granules, each about the size of a large country on Earth. They bubble up, cool, and sink back down in a constant boiling motion. Just above this bubbling surface, there is another layer. This is the chromosphere, or sphere of color. It is a thin, reddish layer of gas that is usually invisible against the bright photosphere. We can only see it during a total solar eclipse, as a brief, beautiful reddish glow around the dark edge of the moon. It is a place of soaring jets of gas called spicules, a fiery, ever-changing forest. The sun is also constantly breathing out a stream of particles. This is the solar wind, a river of plasma that flows from the sun in every direction. It is made of electrons and protons, traveling at hundreds of kilometers per second. It travels past every planet, out to the very edge of the solar system. It is a gentle but persistent current in the vast ocean of space. On the sun's churning surface, there are cooler, darker areas. These are called sunspots, and they are like temporary islands on a sea of fire. They are caused by intense magnetic fields poking through the surface, which slows down the flow of heat from below. They are still incredibly hot, just cooler than the brilliant gas around them. They appear and fade in a slow, rhythmic cycle, like deep breaths taken by the star itself. Sometimes a sunspot can erupt in a sudden flash of light. This is a solar flare, a powerful explosion of energy. It sends a wave of radiation and charged particles out into space, a silent storm of light. These flares are a display of the sun's immense, untamed power, a sudden exhalation of energy into the cosmos. The sun has its own atmosphere, a ghostly halo called the corona. It is only visible during a total solar eclipse, when the moon blocks the sun's bright face. This crown of light is millions of degrees hotter than the surface below, a quiet, shimmering mystery that scientists are still trying to understand. It stretches millions of miles into space, a faint, ethereal crown for a star. Our sun is middle-aged, about 4.5 billion years old. It has been burning steadily for a very long time, a reliable source of light for its family of planets. But it will not burn forever. In about 5 billion years, it will run out of hydrogen fuel in its core. It will then swell up, becoming a red giant, and its outer layers will expand to swallow the inner planets. A slow, inevitable change at the heart of our system. After its time as a red giant, the sun will shed its outer layers. These layers will drift away into space, forming a beautiful, glowing cloud called a planetary nebula. At the center, the sun's old core will remain. It will become a white dwarf, a small, dense and cooling ember. It will be about the size of Earth, but incredibly heavy, a final, quiet remnant of our star, slowly fading into darkness over trillions of years. Our journey begins with the world closest to this great star. Its name is Mercury, a small, rocky planet. It races around the sun faster than any other, completing its year in just 88 Earth days. It is a swift little world, forever tied to the star it circles. Mercury is a world of extreme temperatures. The side facing the sun becomes hot enough to melt lead, reaching over 400 degrees Celsius. But on the side facing away from the sun, the temperature plummets to hundreds of degrees below freezing, with no atmosphere to distribute the heat. It is a world of fire and ice, with no air to balance the two. This tiny planet has almost no atmosphere. It has a very thin layer of atoms, called an exosphere, blasted off the surface by sunlight and the solar wind. But this is not an atmosphere you could breathe or feel. This means the sky on Mercury is always black, even in the daytime. The stars are always visible, silent witnesses in a dark sky. The surface of Mercury is covered in craters, a testament to a long history of impacts. But it is also covered in long, winding cliffs. These cliffs are called scarps, and they formed as the planet's core cooled and shrank long ago. The planet's crust buckled and cracked as it contracted. It is as if the planet is a drying piece of fruit, its skin slowly wrinkling over billions of years. A story of a world getting smaller. For such a small planet, Mercury has a surprisingly large iron core. This heavy heart makes up a huge portion of the planet's mass, perhaps 85% of its radius. This gives Mercury a surprising density, a hidden weight within its small frame. It is thought that a giant impact early in its history may have stripped away much of its original lighter crust and mantle, leaving behind this dense, iron-rich world. Even on this sun-scorched world, there is ice. In the deep craters near Mercury's poles, there are areas that are forever in shadow. The sun's rays never reach the bottom of these craters, allowing water ice to exist in the permanent, freezing dark. It is a strange paradox. Frozen water hiding on the planet closest to the sun. A small pocket of cold hidden from the star's relentless glare. A single day on Mercury is longer than its entire year. The planet spins on its axis very, very slowly. It has a strange 3.2 spin-orbit resonance. This means it rotates on its axis exactly 3 times for every 2 orbits it makes around the Sun. This means the Sun moves across its sky at a crawl, taking a very long time to rise and set. It is a world where time itself seems to move differently, slowly and deliberately. Mercury has a very faint, comet-like tail. It is made of sodium atoms, blasted off the surface by the solar wind and the pressure of sunlight. This ghostly tail is invisible to our eyes, stretching for millions of miles behind the planet. It is a secret trail left behind as the planet speeds through space, a whisper of a world. The planet's orbit is also unusual. It is not a perfect circle. Mercury follows a very elliptical path, a stretched-out oval. This means its distance from the Sun changes a lot during its year. This changing distance contributes to its strange, slow days and the extreme temperatures on its surface, a world that dances closer and then farther from the fire. One of the largest features on Mercury is a huge impact crater. It is called the Caloris Basin, which means basin of heat. It is one of the largest impact basins in the solar system. Created by a giant asteroid long ago, the impact was so powerful, it sent shockwaves through the entire planet, creating a jumbled, chaotic terrain on the exact opposite side. It is a scar that tells the story of an ancient planetary collision. We travel outwards to the next planet. This is Venus, a world shrouded in thick, pale yellow clouds. It shines brightly in our sky, often called the morning star or the evening star. It is the second brightest natural object in the night sky after the moon, a beautiful calm beacon at dawn or dusk. Beneath those beautiful clouds, Venus is a hostile place. It has a thick, crushing atmosphere, mostly made of carbon dioxide. The pressure on the surface is over 90 times that of Earth, equivalent to being a kilometer deep in the ocean. The air is so dense it behaves more like a fluid than a gas. It is a world that would gently, but completely, crush you. This thick atmosphere has created a runaway greenhouse effect. The clouds trap the sun's heat, making Venus the hottest planet in the solar system. It is even hotter than Mercury, even though it is farther from the sun. The surface temperature is a uniform 460 degrees Celsius, hot enough to melt lead. It is a permanent, sweltering world, wrapped in a blanket of heat. Venus spins backwards, in the opposite direction to almost every other planet. This is called retrograde rotation, and it spins incredibly slowly, slower than any other planet in the solar system. A single day on Venus, from one sunrise to the next, is longer than its year. This may be the result of a massive collision in its past, or the thick atmosphere dragging on the planet's rotation, a slow, lazy spin in the wrong direction. Because of this strange rotation, the sun on Venus rises in the west and sets in the east. It is a world where the familiar rhythm of day and night is reversed. It is also stretched out over a very long time, with 117 Earth days between each sunrise. It is a world of slow sunrises and even slower sunsets. The clouds of Venus are not made of water. They are made of droplets of sulfuric acid. It rains this acid high in the atmosphere, but the surface is so hot, the rain evaporates long before it can ever touch the ground. This phenomenon is called virga. It is a world with a corrosive rain that never falls, a storm that can never reach the ground. The surface of Venus is a vast volcanic plain. It is covered in thousands of volcanoes, far more than any other planet in our solar system, some of which may still be active. Ancient lava flows have paved over the entire planet, creating a smooth but desolate landscape. We see strange volcanic features called coronae and pancake domes, shapes not seen on Earth. It is a land shaped by fire, hidden forever beneath the clouds. Unlike most other planets, Venus has no moons at all. It travels through space alone, without a single companion. It is also one of only 2 planets without a global magnetic field. Its slow rotation means its molten core cannot generate a dynamo effect like Earth's. It is a solitary world, a bright jewel with no smaller lights orbiting it, a lonely wanderer in the dark. The surface of Venus is surprisingly young, geologically speaking. It seems to have been completely resurfaced by volcanic activity a few 100 million years ago. One theory suggests the planet's crust doesn't move in plates like Earth's, but instead builds up heat until the entire surface melts in a massive to global volcanic event. It is a world that might periodically and catastrophically renew its own skin. There are strange features on Venus called pancake domes. These are circular, flat-topped volcanoes that look like giant pancakes. They were formed by thick, slow-moving lava erupting from a central vent and spreading out in an even circle. They are a sign of a unique kind of volcanism, a quiet and sluggish eruption, creating a strange, smooth landscape. Now we arrive at a familiar place, a blue and white marble in the void. This is the 3rd planet, our home, the Earth. It is a world teeming with life, a special fragile haven in the vastness of space. Its name comes from Old English and Germanic words, meaning simply the ground, a humble name for such a vibrant world. Earth is the only planet we know of. with liquid water on its surface. Great oceans, lakes, and rivers cover over 70% of our world. This water is essential for all life as we know it, a precious and rare substance in the solar system. Our planet sits in a special zone, called the habitable zone, where it is not too hot and not too cold for water to be a liquid, the lifeblood of our planet. Our world is wrapped in a protective blanket of air. We call it the atmosphere. It is made mostly of nitrogen and oxygen, and it shields us from the sun's harmful radiation. It also keeps our planet at a comfortable temperature, preventing the extreme swings seen on Mercury. It is a gentle buffer against the cold of space, and the reason our sky is blue. Deep within the Earth, a spinning core of liquid iron creates a magnetic field. This field extends far out into space, creating an invisible bubble around our planet called the magnetosphere. It deflects the solar wind, a stream of charged particles from the sun. This protects our atmosphere from being stripped away over time, an unseen shield guarding our world. The Earth is tilted on its axis by about 23.5 degrees. It is like a spinning top leaning to one side. This gentle tilt is the reason we have seasons. As we orbit the sun, different parts of the Earth receive more direct sunlight, giving us summer, autumn, winter, and spring. It is a simple tilt, but it is the quiet reason for the changing of the year. Our planet is not perfectly round. Because of its spin, it bulges slightly at the equator and is slightly flattened at the poles. It is a tiny bit wider than it is tall, an oblate spheroid. It is a small imperfection, a quiet result of its constant gentle turning. The highest point on Earth is Mount Everest, but the point farthest from the Earth's center is actually a different mountain. It is Mount Chimborazo in Ecuador. Because of the equatorial bulge, its peak is farther from the center of the Earth than Everest's peak. It is a quiet, geographical secret, a different way to measure what is highest. Our planet's surface is broken into giant pieces, like a cracked eggshell. These pieces are called tectonic plates, and they are slowly moving. They float on the semi-molten layer of rock beneath them. This movement causes earthquakes, creates mountains, and opens oceans. It is a slow, powerful process that constantly reshapes the face of our world. When the solar wind interacts with our magnetic field, it creates a beautiful display of light. These are the auroras, the northern and southern lights. Charged particles from the sun are channeled towards the poles, where they collide with atoms in our atmosphere. This collision makes the air glow in beautiful curtains of green, pink, and blue light, a silent light show in the polar skies. Our planet also has a wobble, a slow change in the orientation of its axis. This is called precession, and it is like the slow wobble of a spinning top as it slows down. This cycle takes about 26,000 years to complete. It slowly changes which star is our North Star, a slow, silent drift in our celestial bearings. Our planet has a constant companion, the Moon. It is our only natural satellite, a silent, grey world that orbits us. It has been our neighbour for billions of years, a familiar, watchful face in the night sky. It is the 5th largest moon in the solar system, and it is larger relative to its planet than any other moon. the moon's gravity gently pulls on Earth's oceans. This pull is what creates the tides, the slow, rhythmic rise and fall of the sea. The sun also has a tidal effect, but the moon's is stronger because it is so much closer. It is a daily dance between our world and its moon, a quiet conversation spoken in the language of water. The moon is slowly, very slowly, moving away from us. Each year, it drifts about 1.5 inches farther from Earth. This is because it is stealing a tiny amount of Earth's rotational energy. As the moon moves away, the Earth's rotation slows down, and our days get slightly longer. Millions of years ago, it was much closer and appeared much larger in our sky. A neighbor that is slowly saying goodbye. The moon is tidally locked with Earth. This means it spins on its axis at the same rate that it orbits us. The result is that we always see the same side of the moon. This is a common fate for moons that orbit close to their planets. Its face is forever turned towards us, a constant, unchanging gaze. People sometimes speak of the dark side of the moon, but it is not always dark. It is simply the far side. It receives just as much sunlight as the side we see. We just never get to see it from Earth. The only time it is truly dark is during a lunar day on that side. It is a hidden landscape, the secret face of our closest neighbor. The surface of the moon is covered in a fine, grey dust. This dust is called regolith, and it is made of tiny sharp particles of rock and glass. It was created by billions of years of tiny meteorites hitting the surface, with no atmosphere to burn them up. It is a soft blanket of cosmic debris that holds the footprints of the few humans who have walked there. The most likely story of the moon's birth is one of a great collision. Long ago, when the solar system was young, a planet-sized object we call Theia may have crashed into the young Earth. The debris from this giant impact was thrown into orbit and eventually came together under its own gravity to form our moon. It is a child born from a cosmic crash that settled into a peaceful orbit. The moon has no atmosphere, and therefore no weather. There is no wind, no rain, no clouds. The sky is always black. The footprints left by the Apollo astronauts will remain there for millions of years, undisturbed in the silent vacuum, a quiet monument to a brief visit. The dark patches we see on the moon's surface are not seas, as was once thought. They are called maria, which is Latin for seas. They are vast plains of dark, volcanic rock. Long ago, large asteroids hit the moon, and lava from the interior flowed up to fill the craters, creating these smooth, dark plains, ancient scars flooded with hardened lava. The moon is not completely silent. It experiences moonquakes. These are caused by the Earth's gravitational pull, and by the cooling and contracting of the moon's interior. They are much weaker than earthquakes, but they show that our neighbor is not a completely dead world. It still has a few faint tremors in its heart. Beyond our blue world lies the red planet. This is Mars, a dusty, cold desert world. Its rusty color has fascinated humanity for centuries, a warm beacon in the cold night sky. It is named after the Roman god of war, but it is a world of deep and profound silence. The red color of Mars comes from iron oxide, which is just a simple rust. The rocks and fine dust on the surface contain a lot of iron. Over billions of years, this iron has reacted with the small amounts of oxygen that were once in its atmosphere, and it rusted. This gives the entire planet its familiar reddish hue, a world the color of old, weathered metal. Mars has a very thin atmosphere. It is more than 100 times thinner than Earth's. It is mostly carbon dioxide, and it offers little protection from the sun's radiation or the deep cold of space. The air is too thin to breathe, and the pressure is very low. This thin air also means that sound would travel differently, sounding faint and muffled, a world of profound and echoing silence. On the surface of Mars stands the largest volcano in the entire solar system. It is called Olympus Mons, and it is 3 times taller than Mount Everest. It is a gentle giant, a shield volcano with slow, sloping sides. It grew so large because Mars does not have tectonic plates, so the volcano sat over a hotspot for millions of years, growing ever larger, now long dormant, a mountain that touches the edge of space. Mars also has the largest canyon in the solar system. It is called Valles Marineris, a system of canyons that stretches for thousands of miles, as long as the entire United States. It is far longer and deeper than Earth's Grand Canyon. It is not thought to be carved by a river, but a great tectonic crack that formed as the planet cooled, a great scar on the planet's face, a wound from a violent tectonic past. At the poles of Mars, there are bright white ice caps. They are made of a mix of water ice and frozen carbon dioxide, also known as dry ice. These caps grow and shrink with the Martian seasons, which are much like Earth's, because Mars has a similar axial tilt. They are like the slow, frozen breath of the planet. Mars is not alone. It has 2 small moons. Their names are Phobos and Deimos, which mean fear and panic. They are not round like our moon, but are small and lumpy, more like captured asteroids than true moons. They are dark and cratered, 2 little potatoes orbiting the red world. One of these moons, Phobos, is slowly getting closer to Mars. The planet's gravity is gently pulling it inward. In about 50 million years, it will either crash into Mars or be torn apart by gravity, forming a faint ring around the planet. It is a moon with a slow, inevitable doom, destined to become part of the world it orbits. There is strong evidence that liquid water once flowed on Mars. We see ancient riverbeds, deltas, and lake beds carved into its dry surface. Rovers have found minerals that only form in the presence of water. Long ago, Mars may have been a warmer, wetter world with a thicker atmosphere. The planet today is a dry memory of a watery past. Mars is a world of giant dust storms. These storms can sometimes grow to cover the entire planet, hiding the surface from view for weeks at a time. The fine red dust is whipped into the thin atmosphere by strong winds, creating a global haze. It is a planet that can disappear behind a veil of its own dust, a world of red silent blizzards. The Mars rover Opportunity found strange, tiny spheres of a mineral called hematite. These were nicknamed blueberries, though they are grey in colour. On Earth, these spheres usually form in water. Their discovery was another piece of evidence, suggesting that Mars was once a much wetter place, a world that left behind small stone clues of its watery history. Between the rocky inner planets and the gas giants, there is a vast, empty-looking space. This space is not entirely empty. It is home to the asteroid belt. It is a wide, sparse ring of rock and metal, all orbiting the Sun in a slow, silent procession. It lies in the gap where a planet might have formed, but Jupiter's immense gravity prevented it. These asteroids are rocky remnants from the formation of our solar system. They are the leftover building blocks of planets that never came together to form a world. They are cosmic fossils, drifting in the dark for billions of years. Each one is a small time capsule from 4.5 billion years ago. The largest object in the asteroid belt is a dwarf planet named Ceres. It is large enough that its own gravity has pulled it into a nearly round shape. It is a small world in a belt of debris, with mysterious bright spots of salt on its surface. These spots are thought to be remnants of a salty ocean beneath its crust, a lonely, shining outpost. If you were to gather all the asteroids in the main belt and put them all together, their total mass would be less than that of our own moon. The asteroid belt is mostly empty space, a vast and lonely expanse. Spacecraft can fly through it without any danger of collision, with rocks drifting millions of miles apart. Some asteroids even have their own tiny moons. The asteroid Ida, for example, has a tiny companion named Dactyl. It was the first asteroid moon to be discovered. It is a small rock orbiting a larger rock, a miniature solar system in the vastness of the belt, a quiet testament to gravity's reach. There is another large object in the belt, named Vesta. It is the second largest asteroid, and it is not round like Ceres. It has a giant impact basin at its south pole, where it was struck by another large asteroid. Pieces of Vesta were blasted into space, and some have even fallen to Earth as meteorites, allowing us to hold a piece of this distant world in our hands. Asteroids are not all the same. They come in different types, based on what they are made of. There are C-type asteroids, which are dark and carbon-rich. There are S-type asteroids, which are stony and made of silicate minerals. And there are M-type asteroids, which are metallic and rich in iron and nickel, the leftover cores of shattered protoplanets. Not all asteroids live in the main belt. There are groups of asteroids called Trojans that share an orbit with a larger planet. Jupiter has the largest collection of Trojan asteroids. They travel in two large swarms, one group ahead of Jupiter in its orbit, and one group behind, trapped in stable points of gravitational balance. Far beyond the asteroid belt, we reach the realm of giants. Here lies the king of planets, Jupiter. It is the largest planet in our solar system, bigger than all of the other planets combined. It is a vast ball of swirling gas, with no solid ground to stand on. It is a world of clouds and storms, a majestic and powerful presence in the solar system. Jupiter is a gas giant, made mostly of hydrogen and helium, the same elements that make up the Sun. Deep inside, the pressure is so immense that the hydrogen is compressed into a liquid. Deeper still, it becomes a liquid metal. This rotating layer of metallic hydrogen is what generates Jupiter's powerful magnetic field. It is more like a failed star than a rocky planet, a star that never ignited. The most famous feature on Jupiter is the Great Red Spot. It is a gigantic storm, a high-pressure system wider than the entire Earth. It has been raging for at least 400 years. It is a permanent hurricane, a swirling vortex of crimson clouds. The storm rotates counterclockwise, and its winds are incredibly fast, a storm that outlasts centuries. Jupiter's surface is covered in beautiful stripes and swirls. These are bands of clouds, moving in opposite directions at high speeds. The lighter-colored bands are called zones, and the darker bands are called belts. The different colors are caused by different chemicals and temperatures in the clouds, painting the planet in shades of orange, white, and brown. Jupiter spins faster than any other planet. A day on Jupiter is less than 10 hours long. This rapid rotation causes the planet to bulge at its equator and flatten at its poles. It is a world in a constant, dizzying spin. This rapid spin is also what stretches its storms and clouds into long bands. This fast spin also helps to generate a powerful magnetic field. It is the strongest of any planet in the solar system, thousands of times stronger than Earth's. This field traps particles from the solar wind, creating intense radiation belts around the planet. These belts would be deadly to unprotected astronauts, an invisible, dangerous halo. Like Saturn, Jupiter also has rings. They are very faint and dark, made of tiny dust particles kicked up from its inner moons by micrometeorite impacts. They were a surprise discovery by the Voyager 1 spacecraft. They are a subtle and delicate feature around such a powerful planet. Jupiter has a huge family of moons. Over 90 have been discovered and named. The 4 largest are known as the Galilean moons, because they were discovered by Galileo Galilei in 1610. Their names are Io, Europa, Ganymede, and Callisto, and each one is a unique world. The moon Io is the most volcanically active body in the solar system. Its surface is covered in hundreds of volcanoes, constantly erupting sulfur and ash. This intense volcanism is caused by Jupiter's immense gravity, which squeezes and stretches the moon as it orbits. This tidal heating melts its interior, a world in constant fiery turmoil. The moon Europa is a smooth, icy world. Its surface is a shell of frozen water, crisscrossed with long cracks and reddish-brown ridges. Beneath this ice shell, scientists believe there may be a vast ocean of liquid salt water, kept liquid by the same tidal heating that powers Io's volcanoes. It is a hidden sea that could potentially harbor life, a world of quiet, deep mystery. The moon. Ganymede is the largest moon in the entire solar system. It is even bigger than the planet Mercury. It is a world of 2 terrains, dark, ancient, cratered regions, and younger, lighter regions with grooves and ridges. It is the only moon known to have its own magnetic field, generated by its liquid iron core, a moon that acts like a small planet itself, a king among moons. And the moon Callisto is the most heavily cratered object in the solar system. Its surface is ancient and dark, and has not changed much in billions of years. It shows no signs of geological activity. It is a frozen record of the solar system's violent past, a silent witness to ancient impacts. Moving farther out, we come to the jewel of the solar system. This is Saturn, a beautiful, pale yellow gas giant. It is the second largest planet, and it is famous for its stunning system of rings, floating serenely in the dark. It is a world of quiet elegance and gentle beauty. Saturn's rings are not solid. They are made of billions of small particles of water ice and rock. These particles range in size from tiny grains of dust to pieces as large as a house. They orbit Saturn in a thin, wide disk. The rings are bright because they are made of highly reflective water ice, like a silent, spinning record made of ice. The rings are incredibly thin for their size. Though they stretch for hundreds of thousands of miles across, they are mostly less than 100 feet thick. If you made a scale model of the rings a mile wide, they would be thinner than a sheet of paper. They are a cosmic illusion of substance, a delicate sheet of orbiting ice. Saturn is the least dense planet in the solar system. It is so light for its size that if you could find a bathtub big enough, Saturn would float. It is made mostly of hydrogen and helium, the lightest elements. It is a giant airy world, a puffball of a planet, lighter than water. At Saturn's North Pole, there is a strange and mysterious storm. It is a six-sided jet stream, known as the hexagon. Each side of this hexagon is wider than the Earth. It is a stable and long-lasting weather pattern, a bizarre and beautiful geometric shape in the clouds, a perfect shape created by the wind. Saturn is a world with a very large family of moons. Over 140 have been confirmed, each with its own unique character. They range from giant worlds with atmospheres to tiny, captured rocks that look like sponges. It is a diverse and crowded family, a miniature solar system of its own. The largest of Saturn's moons is Titan. It is a fascinating world, the only moon in the solar system with a thick, dense atmosphere. Its air is mostly nitrogen, like Earth's, but it is thick and hazy with orange smog. This smog is created by sunlight breaking down methane, hiding the surface below. On the surface of Titan, it is so cold that water is as hard as rock, but there are lakes, rivers, and seas made not of water, but of liquid methane and ethane. It rains methane from the sky and carves river channels into the icy ground. It is a strange, cold reflection of Earth's own water cycle. Another of Saturn's moons, Enceladus, is a small, bright world of ice. It is one of the most reflective objects in the solar system. It has huge geysers near its south pole that spray jets of water ice and vapor far out into space. These jets contain salt and simple organic molecules, suggesting a liquid water ocean lies beneath the ice, a moon that is building its own ring. There is a small moon of Saturn named Mimas. It has a single, enormous crater on its surface, named Herschel. This crater is so large relative to the moon's size that it makes it look like the Death Star from the movies. The impact that created it nearly shattered the little moon, a cosmic coincidence, a familiar shape in a far-off place. Another moon, Iapetus, is a world of two faces. One half of the moon, the side that faces forward in its orbit, is as dark as asphalt. The other half is as bright as snow. It is thought that the dark material is dust collected from another of Saturn's moons, Phoebe. It is a strange, two-toned world, as if it was painted half black and half white, a mystery we are still trying to solve. Our journey now takes us to the distant, cold outer reaches. Here we find Uranus, the seventh planet from the Sun. It is a pale, featureless blue-green world with a quiet and mysterious nature. It was the first planet discovered with a telescope. In 1781, a planet of serene, icy blue. Uranus is unique because it is tilted completely on its side. Its axis of rotation is tilted by 98 degrees, so it is basically orbiting the Sun on its side. While other planets spin like tops, Uranus rolls along its orbit like a ball. This extreme tilt means its seasons are very long and strange, with each pole facing the Sun for 42 years at a time. A world with a sideways life. This sideways tilt might be the result of a massive collision long ago. A body the size of Earth may have crashed into the young Uranus, knocking it over. Or perhaps it was pulled over by a large moon that was later ejected. It is a quiet planet that carries the memory of a violent past or a lost companion. Uranus is an ice giant. Its interior is made of a hot, dense fluid of ices, like water, methane, and ammonia, surrounding a small rocky core. It does not have the metallic hydrogen layer of Jupiter and Saturn. It is a different kind of giant, a cold and slushy world. The planet's beautiful blue color comes from methane gas in its upper atmosphere. This methane absorbs red light from the Sun and reflects blue and green light back into space. Its atmosphere is remarkably calm and clear compared to Jupiter and Saturn, giving it a smooth, uniform appearance. A calm, aquamarine world, glowing faintly in the distant sunlight. Like the other gas giants, Uranus also has rings. They are very dark and narrow, and were only discovered in 1977 when the planet passed in front of a star. They are not bright and icy like Saturn's, but dark as charcoal. They are thought to be made of rock and ice darkened by radiation, like ghostly hoops around the planet. The moons of Uranus are named after characters from the works of William Shakespeare and Alexander Pope. Names like Titania, Oberon, Miranda, Ariel, and Umbriel circle this distant world. It is a tradition that gives a touch of poetry to the cold, silent dark. One of its moons, Miranda, has a very strange and jumbled surface. It looks as though it was shattered into pieces and then put back together randomly. It has giant canyons, strange grooved terrains called coronae, and cliffs taller than the Grand Canyon is deep. It is a puzzle of a moon, a patchwork of different worlds in one. Beyond Uranus, we find the last of the giant planets. This is Neptune, a deep, vibrant blue world. It is the eighth and farthest known planet from the Sun. It is a place of extreme winds and deep mystery, a world of deep royal blue. Neptune was the first planet to be found using mathematics, not by accident. Astronomers noticed that Uranus was not moving as predicted. They calculated that another planet's gravity must be pulling on it, and told observers where to look. In 1846, it was found exactly where predicted, a world discovered by the power of thought. Like Uranus, Neptune is an ice giant. It is a similar size and composition, a sister world in the deep outer solar system, but it is a much more active and stormy planet. Its deep blue color is also caused by methane, but some other unknown chemical gives it a richer, more vibrant hue. It has a more dynamic, deep blue atmosphere. Neptune is the windiest planet in the solar system. It has supersonic winds that whip through its atmosphere at more than 1,200 miles per hour. These are the fastest winds recorded anywhere in our cosmic neighborhood. The cause of these extreme winds is a mystery, as the planet is so far from the Sun. It may be driven by heat from its interior, silent storms on a distant world. When the Voyager 2 spacecraft flew by, it saw a huge storm on Neptune called the Great Dark Spot. It was an anticyclone, a high-pressure system similar to Jupiter's Great Red Spot. But when the Hubble Space Telescope looked later, the spot had vanished completely, and a new one had appeared in the Northern Hemisphere. It is a reminder of how quickly Neptune's weather can change. Neptune has a faint and clumpy ring system. Its rings are not uniform. They have bright arcs where the particles are more densely packed. These arcs are thought to be held in place by the gravity of a small moon, Galatea. It is as if the rings are incomplete, still being formed, or slowly falling apart, a delicate, broken necklace. Neptune's largest moon is Triton. It is a strange and cold world, with a thin atmosphere of nitrogen. It is one of the few moons in the solar system that is geologically active, with a young, constantly changing surface. Its surface is a mix of frozen nitrogen, water ice, and carbon dioxide ice, a world that is not frozen in time. Triton has a retrograde orbit, meaning it orbits Neptune backwards, against the planet's rotation. This strongly suggests that Triton was not formed with Neptune. It was likely a dwarf planet from the Kuiper Belt that was captured by Neptune's gravity long ago. It is a visitor that stayed forever, and its capture may have disrupted Neptune's original moon system. The surface of Triton is home to cryovolcanoes, or ice volcanoes. These volcanoes do not erupt molten rock, but a slushy mix of water ice, nitrogen, and methane. Solar energy heats the dark material under a layer of transparent ice, causing pressure to build up. This pressure sends dark plumes of material high into the thin atmosphere, a cold, slow eruption in the faint sunlight. Beyond the orbit of Neptune lies a vast region of icy bodies. This is the Kuiper Belt, a cosmic deep freeze, home to countless comets and dwarf planets. It is the third great zone of our solar system, a wide, dark frontier. It is like a much larger version of the asteroid belt, but made of ice instead of rock. The most famous resident of the Kuiper Belt is Pluto. Once considered the 9th planet, it is now classified as a dwarf planet. It is a small but surprisingly complex world of ice and rock, with a thin, hazy blue atmosphere. It has mountains of water ice and glaciers of frozen nitrogen, a world of stunning variety. Pluto has a giant heart-shaped feature on its surface. This heart is a vast plain of frozen nitrogen, a massive glacier called Sputnik Planitia. This glacier is slowly flowing and changing, showing signs of convection, like a pot of simmering soup. It is a symbol of a world that is far more active and dynamic than we ever imagined. A frozen heart that still beats. Pluto is not alone. It has 5 known moons. The largest is Charon, which is so big compared to Pluto that they are sometimes considered a double dwarf planet system. They are tidally locked, forever showing the same face to each other. The center of gravity for the system is actually outside of Pluto, so they orbit a common point in space, locked in a silent, orbital embrace. The Kuiper Belt is the source of many of our comets. These are the short-period comets, taking less than 200 years to orbit the Sun. They are icy bodies, occasionally knocked from their orbits by the gravity of Neptune or by collisions, and sent on a journey toward the inner solar system. A comet is like a dirty snowball, a mix of ice, dust, and rock. As it gets closer to the Sun, the ice begins to heat up and turn into gas in a process called sublimation. This process creates a glowing cloud around the nucleus called a coma, and a long, beautiful tail. There are two tails, a dust tail that is curved, and a plasma tail that points directly away from the Sun, a temporary visitor with a tail of light. But even beyond the Kuiper Belt, there is one last great boundary. It is a theoretical region called the Oort cloud, a vast spherical shell of icy debris. It is so far away that light from our Sun takes more than a year to reach it. It marks the true gravitational edge of our solar system, the deep dark attic of our cosmic home. The Oort cloud is thought to be a giant spherical swarm of trillions of icy bodies. It surrounds our entire solar system, like a giant bubble. We have never seen it directly. Its objects are too small, dark and far away. But we see the long-period comets that are occasionally nudged from their distant orbits and fall towards the Sun, messengers from the deep dark. The entire solar system, from the Sun to the edge of the Oort cloud, is moving through the galaxy. We are traveling inside a protective bubble created by the solar wind. This bubble is called the heliosphere, and it shields us from much of the harsh radiation of interstellar space. It is a quiet cocoon for our planetary family, a vessel on a cosmic journey. The edge of this bubble, where the solar wind slows down and meets the space between stars, is called the heliopause. It is the final frontier of our Sun's influence. Two spacecraft, Voyager 1 and Voyager 2, have crossed this boundary. They were launched in the 1970s and are now traveling in true interstellar space, silent ambassadors to the stars. These Voyager spacecraft carry a message. Each one has a golden record, a gold-plated copper disc containing sounds and images of Earth. There are greetings in many languages, music from different cultures, and pictures of our world and our species. It is a message in a bottle thrown into the cosmic ocean, a hopeful whisper sent out into the great silence. Our journey through the quiet worlds of our solar system is coming to a close. We have traveled from the fiery heart of the Sun to the silent, frozen plains of Pluto and beyond. Each planet, each moon, is a quiet testament to the slow, graceful laws of the universe. They drift in the dark, in perfect, silent harmony. If you enjoyed this quiet journey, I am glad you found your way here. It helps others find this peaceful corner too, one sleepy soul at a time. And now, just breathe. Let your eyes close, and let the quiet, silent planets lull your thoughts to sleep. Good night.